So to find the distance between two parallel lines, which we know these are because the slopes are both 3. So the slope of the line is 3. To find the distance between the two lines, we need to find a perpendicular that passes through both lines. So if we think about the graph, let's go ahead and do that so that we can identify some points and figure out what to do from there. Okay, now that the lines have magically appeared, we are going to look at where to find this. So I could use this point right here because it's an easy point to use, or I could use this one right here, but I need the perpendicular distance from either of those 2 points. So let's think about that, what that means. I'm going to use this one right here, which is -4, 0. And then I'm going to draw a perpendicular in another color. So I'm going to go ahead and draw that in green. So something that's slightly, might look perpendicular. It's not exactly perpendicular, but it gives me an idea of what it is that I need to find. So in order to find distance, I need to find this point right here, the point of intersection between the perpendicular and the black line, which is the first equation, and I'd need to find the distance between those 2 points. So I'd need this distance right here. So how am I going to do that? Well, the first thing to do is find the slope of the perpendicular. So if the slope was 3, then the slope of the perpendicular is -1/3. Once I know that, I can use one of the points that I need, which is that one, to find the equation of that perpendicular line. So if the point was 0, -4, which is the intercept, right, the y-intercept of the second line, then I have that -4 is equal to -1/3 times 0 plus b, which means that b is -4. So the equation of my perpendicular line is y equals -1/3 x minus 4. Now that I have that, so that's that equation, that's that green line right there. So now that I have that, I need to find the intercept of the green line, which is -1/3 x minus 4, and the black line, which is y equals 3x minus 1. So what I'm going to do is I'm going to go ahead and multiply by 3 so that my line doesn't have fractions. So I'm going to get 3y equals -x, or the opposite of x, minus 12. And my system becomes y equals 3x plus 1 and 3y equals -x minus 12. Now I'm going to multiply the second equation by 3 again because I see that if I do that, then my x's will cancel out. So I'm going to go ahead and do that, and I'm going to get that y equals 3x plus 1 and 9y equals the opposite of 3x, or -3x, minus, and 3 times 12 is 36. If I combine those, I get that 10y is equal to -35, and that y is equal to -7/2. If y is equal to -7/2, then I can substitute and get that -7/2 is equal to 3x plus 1. I'm going to subtract 1, which is 2 halves, so -7 halves minus 2 halves equals 3x. So that's -9 halves equals 3x. I'm going to divide by 3 on both sides, which is the same as multiplying by the reciprocal. So x is -3 halves. So that point of intersection that we talked about, which is this point right here, is -3 halves, comma, -7 halves. So I'm going to write that here. So the last step is to find the point of intersection, the distance between that point and that point. And I know that the coordinates of that were 0, -4. So we're going to write that down, 0, -4. And I'm about to make my screen a little smaller so that we can go ahead and find the distance. So then the distance is equal to the square root of negative 3 halves minus 0 squared plus